Hello and welcome. Get out your notes. Put today's date at the top. Entitle this lecture 2. We're going to be talking about metric units today. All right, first thing for our notes today, let's talk about what our SI units are. You don't need to know what SI stands for, but it basically means metric. All right, when we're measuring things in metric, here we have our 7 most basic things. When we're measuring in metric, we're going to use these units. And then we might attach a prefix to adjust them, but this is what the base is. For length, it is meters. All right. If we're doing things in metric, we never use feet or yards or inches. It's always meters, which can then be adjusted with a prefix if we're dealing with something really big or really small. Mass, the metric unit of mass is grams. Temperature, Kelvin is the SI unit, although Celsius works for most things because we tend to just worry about temperature differences. And with Kelvin and Celsius, it's the same. Time, the basic unit is a second. Amount of a substance, our basic unit is the mole. Electric current is going to be ampere. We just call them amps. And then luminous intensity or brightness is measured in lumens. All right, so all of these, you do need to know all of these, but the ones we're going to focus on the most are meters, grams, and although it's not on here because it's not technically an SI unit, liters for volume. All right. Okay, so the next thing I want to talk about are prefixes and how they make metric units even more useful. And that's because it can help us talk about really tiny things and really big things with the same units. So let's draw a picture together in our notes here. So let's say I want to measure something really big, like a mountain. Just do a real cartoonish mountain. And I want to measure how wide the base of that mountain is. Well, if I'm doing it in meters, then I might end up with a really big number, but I don't want to have to write all of those digits. So prefixes helps us move the decimal point so we don't have to write as many numbers to express a really large size. So this might be kilometers or kilometers. All right, and the kilo there is the prefix that says that each kilometer is 1,000 meters, so I don't need to use as big of numbers. And then let's say we want to measure something really small, like we'll just draw a little bacterium. And better give it some organelles in there. This right here, we still want to measure its length, and length is based off of the meter, but now we'd have to use a really tiny number, and really tiny numbers are a 0 with the decimal point and then a lot of zeros. So we can move the decimal point the other direction to talk about really small things. And so this here, this might be, I mean, if it's a bacteria, we're probably on the scale of micrometers, or probably not all the way down to nanometers, but we'll say micrometer. For the size of that bacterium. So you should draw a little diagram along in your notes. So the prefix helps with measures of very large and small things. So we can still use that same length, a meter, with something as big as a mountain and as small as a bacterium. All right, and let's write out what all of our prefixes are. If I have a billion of something, I have a giga of that something. The most common time we see this is with bytes on a computer. A billion bytes is a gigabyte. All right. Now, what about only a million? Well, that's a mega. 1,000 is a kilo. And 100 of something is a hecto. 10 of something is a deca, and spelled with a K. And so that deals with things very large. Now, once we start moving the decimal point to the other side of the 1, now we're starting to get really small. 0.01 is a tenth. So a tenth of something is a deci. 100th of something is a centi. And 1,000th of something, which would have 2 zeros and then a 1, that is a milli. That's another pretty common one. All right, and I threw in just a couple more for fun. So a milli is 1,000th of something. A millionth of something is then called a micro. And then a billionth is a nano. So a billionth of a second, for example, is a nanosecond. All right, and let's get down the letter abbreviations for these two. Giga is a capital G. Mega is a capital M. Kilo is a lowercase k. Hecto is a lowercase h. And deca is a little d, little a. Deci is just the little d. Centi is just a little c. Milli is just a little m. So milliliter, the m in milliliter, especially if I abbreviate it, ml, comes from milli here. Micro, this gets this Greek symbol that kind of looks like a U. And then nano is a lowercase n. Okay, let's practice some conversions. You should do these along with me in your notes. Here I'm converting a weight that's in milligrams to just grams. So here's how I'm going to do this conversion. I'll start with what I know, the 36.52 milligrams. And then I'm going to multiply by the conversion of grams to milligrams. A milligram is 1,000th of a gram. So 1 gram is going to be equal to 1,000 milligrams. And then multiply straight across the top, multiply across the bottom. There is nothing on the bottom, so we can just leave it at 1,000. Here, this is 36.52 over 1,000. There's milligrams just canceling out. Here, we're going to be left with the unit of grams. And what that essentially means is move the decimal place 3 times. 1, 2, 3. So 0.0, we jumped over an invisible 0 here. 3652 grams is equal to 36 milligrams. Notice it's always going to be the same numbers, but with just the decimal place moved. Okay, let's try another one of these. Okay, for this unit conversion, we need to convert hectometers to decimeters. Let's remind ourselves there's 100 meters in a hectometer. And for a decimeter is just 0.1 meters. So we'll convert to meters temporarily and then convert to decimeters. So 0.0035 hectometers times in 1 hectometer, we find 100 meters. And then I've got, so this will cancel out hectometers and I'll be left with the unit of meters. Now to get it down to decimeters, we know that 1 meter is equal to 10 decimeters. And now those meters will cancel out and I'll be left with just decimeters. So we can just count the zeros to figure out how many times to move the decimal point. We have 3 zeros here. So that 0.0035, if I move the decimal point 3 times, I'll end up with 3.5 decimeters. All right. Okay, another one to practice. 243 decaliters is equal to how many liters? All right, let's remind ourselves deca is when we have 10 of something. So that's 10 liters is a decaliter. So if 1 deciliter is 10 liters, how many liters is 243 decaliters? So let's start with that 243. Let's set this up so that the decaliters go away. We know that in 1 decaliter, we will find 10 liters. So I'm just multiplying, decaliters will cancel out. I'm just multiplying by 10. That just moves the decimal place once. And we get 2,430 liters. And the L is already there, so I don't have to write the unit twice. All right, I'll embed a few more questions for you all to practice with the unit conversions, but that's that for this video. Have a good rest of your day.